Alright, we're going to be talking about relations and functions first. A relation is just a set of numbers, so it could be anything. An example of a relation is the time of day and what temperature it is. This happens to be also an example of a function, a relation that is a function. Not all relations are functions, but for every time of day there can only be one temperature. Time of day cannot be two different temperatures at the same time. And that's how you define a function. There are some steps. Each element of A must be matched with an element of B. Okay. Some elements of B may not be matched with any element of A. So there's some extras over here. Two or more elements of A may be matched with the same element of B. So it could stay, for example, 15 degrees at 4 and at 3. And number 4, an element of A cannot be matched with two different elements of B. Okay, a couple of examples. Decide whether each relation represents y as a function of x. When you're looking at a table of values, what you're really looking for, if it's a function, x cannot repeat. So since we have two of the same x values, this is not a function. Example B, if I'm looking at dots on a graph, these obviously make a parabola, but they don't have them connected. Do any of my x values repeat? Well, I've got an x value of -2, -1, 0, 1, 2. None of them repeated themselves, so this one is a function. When I'm giving an equation and determining if it's a function or not, first thing I have to do is solve for y, so that I can look at the graph. So if I subtract x squared from both sides, I'm going to have y equals 1 minus x squared. The next thing I'm going to do is look at my graph. And just to clarify, I'm going to put a video onto the side to show you how to put it into the calculator and where I'm getting the picture I'm going to draw from. So my graph was an upside down parabola. And to determine if it's a function, we're going to do what's called the vertical line test, which is basically where I can take a vertical line, draw it anywhere in the graph, and it never crosses my graph more than once. So for this case, it is a function. An example of a graph that would not be a function would be a graph like a circle. Okay, a circle, I'm going to draw a vertical line through, and it's definitely going to hit twice. Or a sideways parabola. Go this way. If I draw a vertical line through there, I'm definitely going to cross twice. So these are examples of non-functions. Okay, there is a method to graphing a piecewise function in the calculator. Remember, a piecewise function is piecing two or more functions together. For this one, we're piecing together y equals x squared plus 1 and y equals x minus 1. So what I'm going to do is when I go into my calculator, in my y1, I'm going to put in my first function, x squared plus 1. I'm going to use a division sign. And then I'm going to put in parentheses x less than 0. Close parentheses. I'm going to do the same thing for y2. I'm going to put in my second function, x minus 1. Division sign, parentheses, x greater than or equal to 0. You will find the greater than or equal to, less than, all those signs if you go to second math. So just some notes before you watch the video of me graphing this function. So when I translate that graph over to my paper, put my x and y axes, I'm going to have my first function, which was a parabola coming down. It's going to end with a filled-in circle because it doesn't quite get to 0. My second function started here and went in this direction. So it's a function, it's a piecewise function, but it jumps. It does not connect.